I hope you're having a great day. My name is Roberto Antúnez. And this is our presentation for the Integrative project. Its name, Spin and Splash. Spin and Splash is a new way to refill your 5-gallon jugs. With this new way you can get your gallon clean and fill. Otherwise, in the automatic ones, in which you only get your gallon fill, but not clean.
Hi teacher, my name is Jorge Adrian Calzada Quezada.
Good afternoon, Professor. My name is Guillermo Edwin Rosales Gil.
Hello teacher, my name is Leonardo Reyes Mota. I'm also part of the team that work on Spill and Splash. I'm here to talk about the topics which I chose. First, being topic 2, which is after the presentation. The manner of process that we chose and why. So, the process that we chose was the filling and cleaning of a gallon. Because here, well, we believe that here in Durango, we don't have a fully automatic one. Well, we actually don't. And we believe it could be good having one, Works at the circumstances that we are right now due to COVID. So let me explain the process that's done automatically right now. So first, you take your gallon to one of these centers that are mostly located next to an OXXO. You fill it up, you put it in the gallon, then you fill up, and you take it out. That's all. The problem is, it doesn't go through a cleaning process. Well, that's the automatic one, right? Because there's other ones that have like a person that does the process for you. You give him the gallon and he does all the process. The thing is that he also cleans it. Yeah, that's good, right? Now the problem here is that we don't know if he has his hands clean. We don't know if it's all okay. And due to the COVID right now, being clean is the most important thing right now. So what we want to provide is a clean environment in which you can just take your gallon, fill it up, put it inside a machine, allow it to clean by itself, to get filled by itself, and that's that. That's what we're looking for in our project, and the reason why we chose it.
Where the jug is taken to be filled. In tools we have the jug, and the user has to provide this tool to the person in charge, and finally the lid to close the jug. Well, the manual process consists basically in 2 steps: the cleaning of the jug by the inside and outside of it to kill any bacteria in the surface of this tool, and the filling of the jug with purified water. To explain the manual process in detail, I took the next pictures, considering that there are people who prefers to clean or disinfect the jug at home because of the COVID. So the first step is to rinse the inside of the jug with hot water and also with water mixed with chlorine or soap. The next step is to shake the jug to ensure the cleaning agent reaches all the corners. Then pour the chlorine and hot water out, and finally fill the jug at the desired level.
Okay, so up next we're going to talk about how we went from the manual process that we selected to this automatic process that we now have with the Spin and Splash. And also we're going to be discussing how we justify having arrived at this decision. Let's begin. So first up is how we came up with this automation idea. Now, coming up with a way to automate a manual process isn't always necessarily a very simple, straightforward task. So what me and my team decided to do was break this process into 3 smaller processes, which were the idea brainstorming, the idea selection, and the idea development. Let's dive in and look at each one individually. First up, we have the idea brainstorming. The main question we kept in mind here whenever we were brainstorming was, how can we automate this process? So we know that we want to clean the 5-gallon water jug and that we want to fill it up with water and automate that process as much as we can before delivering a full 5-water-gallon jug to the client. But how exactly? Well, there was different ways that we could do it. The first option that came up was the assembly line. And you can look to the right of this slide and see an image of the notes that we took during that session of brainstorming, jotting down all of the ideas that we could come up with. And as you can see, for the assembly line in green, we had some pros. There was diverse mechanisms that we could learn about and employ in our actual project. It was a complete process from cleaning the water jug to filling it up to putting a lid on it with the little plastic that keeps it sealed. It was a complete process from start to finish. However, it was very expensive, it's very bulky, and it needs at least a person to operate, or at least many mechanisms. So we decided that we weren't going to do this and instead go with a particular filling station. With the particular filling station, we wouldn't be able to do the entire process without adding a lot of complexity, which would increase cost. So if we just decided to do two simple systems, which would be the cleaning and the filling of the water, then it would be a small system, but it would be simpler and it would be more cost effective. So this is the system that we decided to go with. So as mentioned at the end of the last slide, the idea that we decided to select was the particular filling station. This part is essentially the idea selection stage of the process. So there was many reasons, many pros to why we wanted this, and the pros outweighed the cons of not wanting it. Of course, we already mentioned some of these, such as the lower cost to build, the manageable design process. Since it's smaller, there's not that many mechanisms that have to be built, not too many motors, not too many complexities in this system, and it's also a smaller design that we can scale, so it's easier to transport, and overall the particular filling station was the idea for us to go. Once we had the idea, we had to develop it further. How exactly are we going to take this idea and make it into our project? Now, as you can see on this slide, the first question is, how can we justify this decision? We're not asking us this question right now. We've been asking ourselves this question ever since we started this project. It is our firm belief that keeping in mind the end goal will help you through the decision-making process and overall just make the whole design process as smooth as can be. So we kept in mind, how can we justify building a particular filling station design? And we also kept in mind constantly, is it possible to make this simpler? So for example, right here on this slide, you have an image of one of the slides that we used during this brainstorming idea development stage. And essentially what it is, it's the cleaning system. We didn't know if we wanted to use ultraviolet light to kill the bacteria from the 5-gallon water jug. If so, how would that work? Can UV light actually kill bacteria that fast? But we still have to rinse it, don't we? Because you don't want dead bacteria inside your 5-gallon water jug. So instead we decided to go with a spray system where we channel in some sort of cleaning agent. Right here we were thinking about maybe chlorine water, but it might be some sort of soap as well. Spray that into the 5-gallon water jug, rinse it out, clean it on the inside, and then turn that off, and then turn on another valve to send in pressurized water to rinse out all of that soapy or chlorine water that's still inside. But the question here was, okay, we kind of know what we want, but how are we actually going to turn off the valve? What mechanism actually does that? So that's one example of how we did idea development, of slowly building up this project. We knew what we wanted to do, and how exactly are we going to automate this process? Up next, we have another one of the decisions that we had to make during the idea development stage. So this was the gallon jug holder, one of the most essential parts that makes the clean and splash possible, because it connects the cleaning portion of the mechanism to the filling portion of the mechanism. We had two problems here. What design do we have to use to be able to hold on to the gallon jug, to be able to turn it around to switch it between systems? And the other one, what do we do once we actually start filling up the system and the 5-gallon water jug becomes heavier? If it's connected to the axle, it's going to be very heavy and put a lot of strain on that axle. So we had these two ideas to look around it. And the first idea that we came up with, you can see the drawing to the left, that was from one of our teammates. he said, let's use a clamp. And this clamp is going to hold on to the 5-gallon water jug, it's going to turn it around between stations, and once it's time for the filling, the clamp opens up, it drops the 5-gallon water jug so that there's no need for the clamp to hold onto it. And it drops it in such a way that it stays straight, and then the water can start filling it up. That was a great idea. However, the clamp mechanism was a little bit too complex and it required 2 additional motors the way it was originally planned. So that was a pro and a con to that system. The next system was the one that you see to the right. This was by another teammate, and what it essentially said is you have a sort of basket mechanism that once you actuate the main motor, it will turn this gear and bring the basket onto the neck of the 5-gallon water jug and hold it together against a base. And then that way you can turn it around. And the base is designed in such a way that it will distribute the force. It's going to be touching along with the base of the frame so that all of that force is just dispersed vertically and not on the axle. Originally, we decided to go with the second option with the basket. However, once we were designing it on Fusion 360, it proved to be slightly difficult and not practical for what we wanted to. So what we did is we decided to go with a mix of both of these, and here is the result. The final decision was mixing both ideas together. At the top, there is a sort of a ring that we used to hold the gallon in place, which is the idea that we copied from the basket idea. But at the bottom, we have a small mechanism that allows to drop the 5-gallon jug onto the base once it's time to start filling up. That way the axle wouldn't experience all of that strain. And here, of course, is the image sloppily made during that brainstorm idea when we finally had that eureka moment. We know how we're going to make this system work. Last but not least, we come to the project justification stage. So, as mentioned before, throughout the entire design process of how to automate this project, we were thinking about how are we going to justify this project. And during the brainstorming session, the first one, as we were looking for different objects, different prototypes, different examples that did the exact same thing, trying to answer this question right here, are there others like it? We came across many different types that were very similar. So first with the assembly line. The assembly line could actually do the entire process, which at first we thought, well, this is bad. This makes our product look bad. However, we're not trying to compete against an assembly line process. Of course, if you have a long line, you can practically do whatever you want. We are confined to a small space to do as much as we can in that space in the most efficient way possible. Why? Because we decided to compete against different particular filling stations. Now, there's many different models of particular filling stations out there, and almost all of them fill it up for you, but most of them don't wash the 5-gallon jug. However, there are some that do. But the manner in which our product sticks out from those is that those projects require the operator to grab the 5-gallon jug, insert it upside down, close the door, let it clean it, open the door, take it out, put it back in right side up, close the door, and then it starts filling it up before he can take it out and go home. Ours just requires the operator to put it upside down, close the door, push a button, and it will do the rest. It will clean it, and it will turn it around and fill it up, drop it, and then the operator can open the door, put the lid on, and go home. So essentially, we're cutting out a few steps of what the operator actually has to do, making the experience much more smooth line. And so we thought, does it cover the requirements that we need that are being asked of us for this integrative project? And the answer is yes. We are automating a process, and we're concentrating mainly on how do we control this whole process. And we will get more into that later.
Hi, my name's Guillermo, and I'm going to take you step by step through the CAD file for the spinning splash. First up, we have the holder system. Let's begin. The holder mechanism is modeled around a 5-gallon water jug. From here, the first thing we need to design is a circular ring. Now, what the circular ring allows us to do is once the mechanism is up and running, we insert the 5-gallon water jug upside down, and this mechanism keeps it in place. In order to continue building the holder, we have to add a back support. This will hold everything together. At the bottom of the back support, we add this small lock mechanism, which will be actuated with a small stepper motor, which will release the 5-gallon water jug whenever we need it to. From here, we'll add some sidebar supports and some side supports, which will prevent the 5-gallon water jug from moving side to side. And we add some triangular supports just to increase stability. Last but not least, we connect the back support to a central axle system that we can use to spin the entire mechanism and thus the 5-gallon water jug. Great! Up next, we have the frame. Let's dive in and see what that looks like. First, we add the base, which has a rectangular cut so that the lock mechanism from the holder can move through. Then we add the back with an opening for the central axle, and then we add a roof. The base has an opening for the cleaning system, and the roof has another opening for the filling system. Let's go ahead and add some walls so that the frame is complete. And we're also going to add some triangular supports on the inside to hold everything together. After this, on the front of this frame, we're going to add a door holder. Now the door holder has a few designs on it. Notice the circular cuts at the top and bottom of the door holder. These are important. Also important is this rectangular cut that we have right in the middle. So the circular cuts are to insert neodymium magnets that are going to hold the door frame together with the door so that it doesn't open by accident. Here's the neodymium magnets. And the rectangular cut is to add a micro switch like so that we can tell the program when or when not the door is open or closed. After we add this, we can move to the right side to add some hinges, and once we have these, we can add the door. So here's pretty much the main way the frame is going to look. But let's go ahead and move to the back so that we can add a control support. Here we're going to mount the motor, Arduinos, and driver boards, etc. And at the bottom, we're going to add a triangular support just so that it's attached to the main frame. We're going to move to the side to add a control panel that has an opening for a button. And we're also going to add a triangular support for this. Towards the bottom of the frame, in order to elevate it off the ground, we're going to add 4 legs, which are also going to have their own supports to make sure that there is increased stability and it won't fall down. On the back, we're going to add a motor support to mount the motor, as well as a ball bearing so that the central axle can be connected to the motor without putting too much strain on it. And this is how you build the frame for the spin and splash. Up next, we have the tubing system. This system is going to allow us to clean the 5-gallon water jug, and after it does that process, it's going to allow us to fill it up to the desired level. Let's take a look. First, we add a 90-degree elbow tube to which we're going to attach a 3D printed nozzle that is designed in such a way that the pressurized water will exit in a stream-like fashion. From here, we're going to add a T-connector along with 2 90-degree elbow tubes. One will be for channeling cleaning water, and the other will be for channeling rinsing water. In order to turn on or off these waters, we're going to add solenoids, and to attach these to the tubings, we are going to put this type of tubing right here. The filling system is very similar to the cleaning system. First, we add a nozzle that can either be purchased or also 3D printed, which is connected to a 90-degree elbow tube. This in turn is connected to another solenoid which either lets the water pass, that is for filling the 5-gallon water jug, or it turns it off. And we add this small connector to hold it all together. And this is essentially how the tubing system works. Now that we have the holding system, the frame, and the tubing system, it's time to put those together as well as any additional components that we need to be able to call the spin and splash complete. Let's do it. The first thing we must add is the holder. Now recall that the holder has a lock mechanism at the bottom. The way that we control this lock mechanism is with this small stepper motor. This will allow us to hold the actual water jug in place whenever we have to rotate it. After this, we add the main frame. This is what the whole structure looks like together. We turn to the back and recall that we have a ball bearing as well as a central axle system. To this part, in order to be able to rotate the holder, we are going to add a stepper motor, like so. Up next, recall that we have two openings on the roof of the frame and at the bottom. These are for the tubing system. So let's go ahead and add the tubing system so that we can see what that whole system looks like together. Excellent. The next thing we wish to add are the electrical components. So we begin with the Arduino as well as the driver boards that will be used to control the stepper motors. And we also go ahead and put the power supply that will power the entire mechanism. We move on to the front to the control panel. Now this entire system will be actuated through the press of one button, and a green LED and a red LED that we're adding now will notify the user when it is safe or not to open the door. And this is essentially how you assemble the Spin and Splash.
Well, I will talk to you about the components we will need. We will need 10 components for our project. One Arduino Uno for a cost of 400 pesos, one red LED for a cost of 70 pesos, one green LED for the cost of 99 pesos, an EMA 8 steps motor for 597 pesos, an EMA 17 steps motor for a cost of 200 pesos, a pipe T for 25 pesos, 3 solenoid valves for a cost of 400 pesos, 2 stepper motor NEMA driver boards, for a cost of 34 pesos, 4 elbow pucks for 97 pesos, and a connector for puck and solenoid and the solenoid valves. We'll need 3 of them, and they will have a cost of 146 pesos. Well, the consumables we'll need is per cycle, a 5-gallon jug, water and chlorine. Well, we'll need 1 jug, 20 liters of clean water, and like 2 liters of tap water. Also 20 milliliters of chlorine in order to clean the 5-gallon jug. The 5-gallon jug won't cost anything because the customer will bring jars. The water, according to the Conagua, the 20 liters will cost 2 cents, and 2 liters will cost less than 2 cents, less than 1 cent. It is 0.0002 pesos. Finally, the total cost of the components will be 2,150 pesos, and for the consumables will be as low as 35 cents of peso, making this a really cheap project. I think so. Talking about the consumables, the components are not that cheap.
I'm back. Hello. So, as for conclusions of the process that us as future engineers went through to finish this project, the design of this project at least, it was kind of interesting. There are points in which we had other ideas. Like, for example, the whole gallon thing, we were thinking about doing like in a type of a bucket thing. In a bucket that would hold the whole gallon, even when it's getting full. Now, the problem with that was that we weren't sure if the motor was going to be able to hold the whole gallon full, right? Well, maybe it was, but we were going to need to buy a really big motor. which is really economically inefficient. So as for that, we decided to go for the design that my peer showed you earlier. Besides that, I believe that it was just a bunch of trials and errors. Nothing more, nothing less. That's what we went through. We just slap all these ideas together. Okay, let's think. What's usable, what's not. After discussing, we had various brainstorm calls. That's how I like to call them, but they were basically calls in Discord in which we just brainstormed and had all these ideas planned out and decided, okay, this is a must. This is we need this. We don't need this. We actually need this. This is an option. If we can add it, let's do it. If we can't, it's okay. And after knowing what we needed and what we wanted, we started on building, right? At first, we were skeptical about doing wood, but we thought if we actually do the project of good quality, meaning that we would have the accuracy to pour the water before spraying it, we wouldn't have to worry about the water affecting the wood, which is what we're aiming for. And we also tried to be a little bit more economic, effective, because, well, I mean, we are in a quarantine in which working isn't as easy as it was before it. And once we actually started putting everything together, we liked the idea we had. Honestly though, once we finished this, we came up with a lot more ideas. Yeah, we can't add them because we're not going to be ready for the time which this project is due. The video presentation, I mean. But maybe in the future we're going to discuss it, see if we can add more, brainstorm a bit more. Because as engineers, we want to make the best thing possible at our disposal. We don't want to make just any project. We want to do the best we can. And so the process of designing this whole thing is really exciting, you know. We get to use Fusion to not only just do it on paper, but to have a visual representation in 3D of, okay, is this going to fit here? How about we tweak it a little bit and make it a bit sturdier? So, to say that as a conclusion, all I can say is that it was a really good process. I feel like my team and I, we did a lot of work. We did do a lot of voice calls, Discord voice calls, every morning, every night, just to make sure that this design is what we truly wanted. The change from the bucket system that I mentioned earlier to the system that we have right now was talked through from one night to another, if I'm not wrong. I believe that having communication was the most important thing to do when designing this project. I think that's all for my part, teacher.
Last but not least, we arrive at the NAT diagram. A NAT diagram is essentially a bird's eye view of the entire project, specifically in a timeline, allowing you to see far off into the future what you need to do by what due dates. So for example, we have certain due dates that we have to follow by. Add certain wirings, add certain code by a certain date. So how do we break those giant tasks into smaller, more manageable ones so that we can do things not only in a timely manner, but as efficiently as possible and have remaining time to look over to make sure if we need to make any corrections, we can go ahead and do that. And NAT diagram is a very important tool for an engineer for this very particular reason. Let's go ahead and take a look at the 5 NAT diagrams we have made for the next 5 weeks that are coming up in the second quarter of this year. This is the first NAT diagram, and it takes place from October 2nd to October 11th. Let's go ahead and take a look at some of the things that we have to do. So as you can see, 1, 2, and 3, and 4 are all things that begin today. 1 and 2 are referring to the assignments that we have to submit by today, which in this case is this presentation that we're working on and polishing up right now, and number 2 is also the different assignments that we've been working on the past 3 to 4 weeks, which is 1 through 4. Aside from that, we also had to email the professors. The professor that is in charge of our Integrative project tasks us with emailing various professors from our university to ask them for their opinion on our project. So we emailed them, and we have, as you can see in number 4, a 6-day period. We're giving them a 6-day period to be able to respond to us so that we can figure out if there's any changes, any critical changes that we need to make to our project. And that's it for today. Then we begin with next week, which begins on October the 5th, and you can see that in number 5. So for work number 5, we're focusing primarily on actually getting all the wiring that we need to, making the electrical diagrams. So that's what we're doing here. As you can see, we first on Monday discussed the work that we're going to do, and then for a 3-day period, Monday, Tuesday, and Wednesday, each person that had the work divided to them works on that specific task. And then on Thursday, we get together in the morning to discuss, are we doing everything that we can? Do we have everything? We give each other feedback about what we need to do, and if we do need to do something else, then for the next 3 days, we continue working on that. Last but not least, number 9 is on Sunday. We get together one last time. We review everything that we're going to submit during that day. If there's any changes to be made, it should be minimal by this point. If there are, then we change that. And if there isn't, or we're done after that process, then we go ahead and submit the work and get ready for the next week. And that's it for this net diagram. Let's take a look at the next net diagram. The October 12th to October 18th net diagram is shorter, as you can tell. This is because it's only taking place in a 1-week time frame. So, how does this net diagram work? It's almost essentially the same as the way the last net diagram worked. So on Monday, we get together and discuss work number 6, which is essentially a short sort of project presentation, the way the prototype's going to work, and we have to follow this rubric. So we're going to decide what are we going to do and how we're going to divide the work. And just like last week, for a 3-day period, each person's going to do their own work and contribute to it. On Thursday, we're going to meet and discuss the progress, which is on October the 15th, point number 3, for 1 day. And that same day, if there's any additional work that we need to do, then we're going to do that for another 3-day period. And like last week, on Sunday, we get together, we review everything, and we submit work number 6. However, there's also one more thing here, which is point number 6, which is the frame components and tools task. What is this? As you can tell, it takes place throughout the entire week. So, using the other net diagrams that we have that you will see in a moment, we can see that in the future, we have to actually build this project. And that's in about 2 to 3 weeks from now. And before you know it, that time's going to come very soon. So it's very wise to go ahead and start planning ahead and getting all the materials together. This point number 6, task number 6, is essentially just talking about getting all of the wood that you need to build the frame together, getting all of the components, the motors, the driver boards, the Arduinos, the cabling that you might need, and getting the tools that we're going to need to be able to cut through the different woods or metals or whatever we're going to need. Essentially setting everything that we need up to go ahead and start the construction phase. That begins now. And it's only possible thanks to this net diagram because we can visualize what's coming up in a better way. So let's continue to the next diagram to see what next week holds for us. The net diagram for the week of October 19th to October 25 is very similar to last week's net diagram in its structure. So here we're mainly working on work 7, and we get together in the same way. Monday we get together and discuss and divide the work. Work 7 is mainly focused on creating a pseudocode for our Arduino, for the motors that we're going to be using. How are we going to do that? How are we going to control that whole system, making flow charts and flow diagrams? And so essentially everything that has to do with code. That's what work 7 is about. So on Monday we discuss and divide that work. Then we work for 3 days on work number 7. Then we meet and discuss, make sure that we're on track. If we're not, or if there's anything additional that we want to add or remove, then we do that for another additional 3 days. And on Sunday we get together, we review everything, and we submit it. The one thing that is different here, aside from the due dates, is point number 6 again. Last week, we began gathering all of the materials that we needed for building the project. This week, we begin building the frame, the giant box that's going to hold the spin and splash system together. So that's what we're essentially doing on this week. It doesn't necessarily mean that every day we're going to be going at it, but every day we do have to focus on and make sure that by the end of the week, the main frame for the spin and splash is complete. Now, let's take a look at what next week's NAT diagram has in store for us. This NAT diagram takes place from October the 26th to November the 1st, and as you can tell, it's slightly different from the last ones. Why? Because the project, the work that we have to do for this week is an actual presential review, which means that we actually have to build the project now. And it comes in handy having all of those other NAT diagrams, because by this point we've gathered all the tools that we need, we began constructing the frame, and now we can actually put everything together. So, first we get together on Monday with task number 1, and we decide how are we going to plan this week out exactly. Then number 2 tells us that from Monday and Tuesday we get together and all of those cuts for the frame that we made last week, we nail them together. We actually build the frame. Then number 3 takes place on Wednesday, and it's where we put the tubing system together. Should be very simple. Then on Thursday, we add the different components and wiring. This means Arduinos. This means the wiring system. This means the motors. We put all of that together. On Friday, we wish to test the prototype to make sure that it's working. Friday and Saturday are dedicated to testing the prototype. We have test prototype number 1 and number 2, different aspects about it. How much does it hold in these conditions? Do the motors work? Is it working properly? Do we have to make any changes? If we've done everything by this time, if we've done everything right by this point, then hopefully we'll actually get a few hours of sleep this week. If not, then it's going to be a very interesting week filled with caffeine, working late at night. And then on Monday, we submit the assignment, everything that we've done up until this point. Last but not least, let's take a look at the last NAT diagram. The last NAT diagram that we have reaches from November 2nd to November 8th. And essentially what we're doing here is we're doing the final presentation. So on Monday, we get together and we discuss what we need to do and how we're going to divide the work. From Monday to Thursday, we actually do the work. Each person films their own video for the presentation. On Friday, we're going to meet and discuss the progress that we've made. On Saturday, we finish up the presentation, any last little changes that we have to make. And finally, on Sunday, we submit presentation number 2. And essentially, this is how you use NAT diagrams to plan far ahead to make sure that everything you're doing is in a timely fashion. Thank you.
Well, that was all for our part. I hope you have enjoyed the video and everything was understandable and correct for you. Thank you a lot, and I hope you have a great day.